A very good morning to session panelists and participants, and welcome to the third plenary session of the third Cairo Water Week, Climate Change and Water Security. My name is Mohamed, the Executive Project Manager of the GCF funded project in Egypt, Adaptation to Climate Change.
ده PS5 يا جينا، أنا عايز PS3 دي.
It will be my pleasure to moderate this session. I will now share my screen. So, as most of us now know, climate change has now become like a factor in our life. Many aspects of our life have been affected by climate change, and many sectors as well, in particular the water, agriculture, and coastal zone sectors. Climate change poses so many challenges, but also we have opportunities to benefit from those impacts. Today we will have a look in this session at a number of issues: how to adapt to climate change when it comes to water security, how we can mainstream climate change in water resources policies, strategies, and plans, and how we can reduce disasters, the risk of disasters against natural water hazards and climate change impacts. We have today a number of distinguished speakers. We have Mr. Manawa Gattos, the Minister of Water Resources and Irrigation in South Sudan. We also have Professor Mohamed Rami, Director of the Environmental and Climate Change Research Institute in Egypt. We have Ms. Rola Majdalani, the leader of Climate Change and Natural Resources Cluster in ESWA. We have Ms. Tessa Terbastra, MENA Regional Envoy for Water and Energy Security, Kingdom of the Netherlands. Dr. Aris Georgiakos from Georgia Tech. He might not be able to join us today because they have an outage where he lives now in the US. He might be able to join or not. And we also have Dr. Johannes Coleman from WMO. Before we start our session, just a couple of guidelines. Please keep your microphone muted if you are not speaking or asking questions. During the session, please post your questions in the Q&A section of the WebEx platform, or you will have the opportunity to raise your hand and ask during the session, the Q&A session that we will have at the end of the session. I wish you all a pleasant and enjoyable session, and it will be my pleasure to welcome His Excellency Mr. Manawa Peter Gattos, the Minister of Water Resources and Irrigation in South Sudan, and also the member of the Nile Council of Ministers in the Nile Basin. I welcome him, and I would like to invite him to give us his opening speech of the session. Please, Your Excellency.
Yes.
Yeah, it's so great.
Thank you very much. Thanks a lot. So again, a very good morning for session panelists and participants. And welcome to the Climate Change and Water Security plenary session. My name is Dr. Mohamed Ahmed, Executive Project Manager of the GCF UNDP funded project Enhancing Climate Change Adaptation in Egypt. As you might know, climate change has now become like a part of our life. Everyone knows about climate change, and even the lay people know about the impacts of climate change. It has impacts in our daily life, and it has affected many sectors, including the water, agriculture, and coastal zones. Climate change poses a number of challenges, but also it has its opportunities which you can benefit from. Today we are going to look at a number of topics: adaptation to climate change when it comes to water security and how we can deal with that. Mainstreaming climate change in water resources policies, strategies, and plans, and also reduction of risks that are related to climate change and natural water hazards. Today we have a number of distinguished speakers. We have Mr. Manawa Gatos, the Minister of Water Resources and Irrigation in South Sudan. We have Professor Mohamed Rami, Director of Environmental and Climate Change Research Institute in Egypt. We have Ms. Rola Majdalani, Leader of Climate Change and Natural Resources Sustainability Cluster in ISQA. We have Ms. Tessa Tarbestra, MENA Regional Envoy for Water and Energy Security, Kingdom of the Netherlands. We have Dr. Johannes Coleman from WNO. We were supposed to be joined by Dr. Aris Georgikakos from Georgia Tech. Unfortunately, they have an outage now where he lives in the US. So he might or might not be able to join us. We'll see whilst we are going through the session. Before I start the session, a couple of guidelines. Please, whilst you are not speaking or asking questions, please keep your microphone muted. For participants, please either post your questions in the Q&A section of the WebEx platform, or you can always ask your question during the Q&A session that we'll have by the end of the session by raising your hand. I wish you all a pleasant and enjoyable session. I now have the pleasure to welcome His Excellency Mr. Manawa Peter Gatot, the Minister of Water Resources and Irrigation in South Sudan, and also the member of the Nile Councils of Ministers for South Sudan in the Nile Basin. Please, Your Excellency, give us the opening speech.
Dr. Mohamed, it seems he is not able to log into the session now, so please proceed to the second presenter.
Okay. I think His Excellency has an issue now with the connection, so we will wait. We will move to the second presenter. Rami, Director of Environmental and Climate Change Research Institute. Dr. Rami is a former assistant to the Ministry of Water Resources Minister in Egypt for Research and Technology. He had his Master Science and PhD in Computer Science from Colorado State University. He's a well-known figure with so many publications in water and environment journals. We welcome Dr. Mohamed Rami, and we ask him to present his presentation today, Climate Change in Arid Countries, the Risks. I will now ask Dr. Rami to start. Please, Dr. Rami.
Hello, can you hear me?
Yes, Dr. Rami, proceed.
Okay. I will try to make my presentation as short as possible, and I'll try to finish it so we can allow a lot of questions and suggestions. My presentation will go about climate change in arid countries. It will be very simple. We'll talk about two case studies. One of them is sea level rise in the Red Sea. The arid countries and health situation for climate change in Africa, data availability and accuracy, effort towards better projection, and how to minimize the risks, in my opinion. Like almost a year ago, we start NWRC National Water Resources Center. We start a project for developing a decision tool to determine the setback line for the Red Sea shoreline against post-climate change. So we start collecting data regarding environment and sea water rise, digital elevation model, bathymetry for different points and different locations for all the Red Sea, which is almost like 1,400 kilometers. We start, of course, by selecting the GCM, the diversification model, by taking like almost 41, 28 with different versions. So we reached like 40, testing the 40 diversification model against past correction. So with the data available we have from 1979 to 2005, we try to get the best GCM model that can simulate our history. And we try to project the future as best as we can. I don't know how to move the sticky notes. I have to move the sticky notes from my presentation. How can I do that? I'm sure. I'm sure. This is sticky notes. Is this okay? I hope.
Okay, this is good. Okay.
Okay, I'm sorry. Okay, and after we test all the I'm not sure if I'm doing right. Okay, so after we test all the speech model, we rank them according to how accurate this was the historical record. We for rainfall and temperature, we found that MDI ECM is almost the best for simulating the post rainfall and temperature. We generate according to RCP 4.5 and 8.5 the rainfall for 2050 and 2100 for each month to determine where we're going to be having a major change. For out of the 28 classification model, we get also the how much sea level rise in centimeters for the scenario of RCP 4.5 and 8.5, which 77 after in 2100 77 centimeter and almost 1 meter after 100 years for the scenario RCP 8.5. Also, we get the high water level, so we can see what is the worst scenario for seawater rise, and simulate this with the distribution model we generate to get the inundation area or the setback line for different scenarios. And that was the results. This is the results from one of the scenarios, and we can see that the setback line is including different harbors, tourist villages, and also a lot of population area. Now, after we get this result, we start to see it. Now we need to make a major infrastructure for this area, which we're going to cost the government a lot of money and a lot of time. Of course, we need to do this now because later we will cost more. But that question start to be rising from this. How much is the accurate results, and what is the risks if we need in a couple of years or until then we have better data or we can get better simulation model, something like that. Actually, this question not only for Egypt, also for all Arab countries in Africa. All Arab countries in Africa are developing countries. The economics of these regions prevent local government from being able to step for any major project for climate change protection. Moreover, according to IMF, most of these countries in Africa, the Arab countries in Africa, GDP is less than 10K per year, which per capita, which is almost very low. And it's getting this worse that major cities in the Arab countries in Africa are on the shorelines. And according to the United Nations, more than half of the people now living in the cities, and it will increase until 2050. So we need to break this, but actually we need more money. But to convince people or even donation agencies to help in this, we need to be sure that the data we have is correct and getting the best results from what we have. Actually, if you can see the tide gauge according to the IPCC, that until almost 1990, in all Arab countries in Africa, almost the tide gauge there that you can use for checking the results and for predicting the future. It's almost like 2 or 3 gauges in all these countries. And actually, right now, it's still the case for only like a couple of countries that's having like few, like maybe 4 or 5 gauges in all their shoreline, which prevent from getting any accurate results. Also, they're using digital elevation model because they don't have the funds and the technology sometimes to do something like that for getting an accurate digital elevation model. So we're using the global one, which is used almost for the planning, which is the STRM 30 meter, ASTA 30 meter, and the TARA-SAR, the new one is the ALUS, also 30 meter. And all these digital elevation models are in meter, not in centimeter. If you remember that the results show that after 50 years, the CO2 rise will go to 70 centimeters. So cannot represent this one. So also there is a burden for the government and people to do more work for getting better digital elevation model. The centimeter is accurate one to determine how this is going to affect CO2 rise. Well, also in Arab countries in Africa, they have more problem. The Transboundary river basin. Right now, the Yuba basin, Nile basin, and Senegal basin, they suffer from that. The climate change in their country is the major factor. The major factor is the climate change in the upstream countries. Like in Nile basin, almost 85% of water coming from Ethiopia. So actually, I need to study the climate change in Ethiopia, not in other countries. Not yet. I mean, this is a major factor for water sources there. Also in Yuba basin, the major one for Chad actually is Niger and Nigeria. And Nigeria and Niger. Senegal, the same thing. Mauritania are going to be affected by that, but need to study climate change in Senegal. And actually, the data for the upstream countries is almost sometimes not available, it's not accurate, it's not accessible. You can see from the map that this is a map for showing the large gaps in coverage is not covered by any in-situ observations. It can be done by satellite sometimes and reanalysis of the data available there, but as you can see, there's almost no data there. Anyway, in Egypt we step also to get to see the climate change in Upper Nile, which is Blue Nile, Para, and Para basins. We check the global situation model according to the data we have. We need to select one. As you can see, that's in temperature as an example. For Para and for Blue Nile basins, it's the temperature there is between 0.7 and 3. The change between 0.7 and 3. We need, of course, to check which global spatial model can fit the best data we have and the data available there. And also for the Abbara and for the Baro basin. And for the rainfall, you can see some models say that it's going to be decreased by 90%, and some models say that it's going to increase by 20%. The major problem there is how to fit or to make past correction for this model. Actually, if you go to the global observation data set there, which is GHCN and GBCC. In their maps, even in this case, that a big part of this arid countries, the data are missing or incomplete. And even if you can see that there is discrepancy between them, and you cannot get the right one to get the right model to get the right results. And that's the problem. So actually problem for data availability, which you're going to affect the risk, or how to minimize the risk for climate change effect in this countries in Africa, it's a problem. The scarcity of the data is a great problem in Arizona. The data for Transboundary river basin is not accessible. And we have to remember always that we need this scenario so we can make watershed modeling, water management modeling, planning modeling to see how much this the simulation will affect the water resources and how we can reallocate our water and how we are going to get benefit from it. Anyway, also the routing streams gauging report are typically sparse. The high cost of obtaining such a data from few regions can see this in publication but in most cases they don't publish this in quite data that you can use this later. Also, the access to data, it's big problem. It's very low. As an example, for the flow, for example, isolate for most station, difficult access in a rainfall period, the high variability and irregular terms of the flow, lack of suitable cross sections there, so it can determine by putting gauge for level how to determine the flow there. Difficulty for current meter with high sediment, especially in places like Ethiopia, sometimes Para, something like that. Until now, local experience will continue to play the part of design and the modeling of water resources section. Actually, in 2016, almost 30 scientists from all over the world and water resources management, the professors, they are gathered all over the world in CSU. They start to, the session was called Global Water and the Climate Initiative. And actually, the main purpose of this meeting is to get a document to send to the United States Congress and also send it to the different organizations to talk about the global water problems, especially in developing countries, and they produce a document. Part of the document was emphasis on the 3 points: promoting for water data standardization and sharing, increasing access to appropriate data and information, more tools needed for downscaling from global models to projects level given the poor local hydrological and meteorological data available, especially in the developing countries. So, don't have a solution, or this is a very bad case? Well, right now our observation system continues to improve. Right now, even though we're having some in-suits in this stuff from 1950, we still have satellites from 1970. We're having the reanalysis models, climate reanalysis models, which start from 1990, and the integration between all this data can solve part of the problem or can reduce the risk. As an example, here is an example of climate reanalysis model. It's quite promising. It's have been started, some people using it, and we're still checking. They still have some point need to have improvements. Well, for today, integrated observation is the main answer for problem in most countries in Africa. Well, they must use satellites, radar images, gauges, and models. Each one of those have its strengths and weaknesses. But we have to use it to improve the accuracy, reduce the bias, and increase the resolution of the coverage. By putting this work together, we can reach an acceptable level of risk for implementing the mega projects for climate change in health countries in Africa. What we need more than certain strengths, we need to obtain and share reliable data, building cooperation partnership among various stakeholders, building international cooperation, enhance our ability to ask for data from a broad array of different sources. By the end of the day, we need these resources to make hydrological, to combine this to have different hydrological events, or to make some water management models so we can reduce the risk or mitigate the effect of climate change. And of course, we need regional cooperation regarding climate change for transboundary river basins. I would like to thank you. I hope that I didn't take much time, and I hope that it was. Thank you. Dr. Mohamed.
Thanks very much, Dr. Rami. Very interesting presentation. I think you touched upon a very important issue, the data availability, and if it's available, how accurate it is it accessible or not? It can be expensive. And also, it's good that you pointed to how we can improve that by sharing data, collaboration, use of a mix of ground data, satellite data, and also model reanalysis. Thanks so much for the presentation.